Again, we'll get right into the exercise and I'll explain the new commands as we go. Let me explain the topology and our goals for this exercise before we start. First of all, we have two MLSs here. But what is different this time is that there is a layer 3 link between them. This means that these two networks are completely separate. The VLANs in the network on the left, 10 and 20, have nothing to do with VLANs on the right, 30 and 40. They only matter locally. This means that once a packet from VLAN 10 reaches MLS 1 and MLS 1 sees that it wants to get out of that network, say PCA wants to send something to PCF, MLS 1 will remove any VLAN information from that packet and send it to MLS 2. Once MLS 2 receives that packet, it will have no clue what was the original VLAN that packet came from. So how will we actually configure these devices then? Let's start from MLS 1. On the left, on these interfaces where switch 1 and switch 2 connect, Gigabit Ethernet 0/1 and Fast Ethernet 0/24, on that side, MLS 1 is a layer 2 switch. There, we will configure trunk. On the right, on Gigabit Ethernet 0/2, we will configure an IP address. And to do that on a multi-layer switch, there is a specific configuration. The specific configuration is actually only one command. Once you get into interface config mode, you type in no switch port. And the logic here is similar to no shutdown, where switch port is related to layer 2 stuff. So if you switch it off, so to say, you get layer 3 stuff, including the IP address. After no switch port, you can just configure the IP address the same way you would on a router. Next, to use an MLS as a gateway, you need VLAN interfaces. But we already learned that in the previous lesson, so we will repeat the same thing. And finally, if we want the network on the left to be able to communicate with the network on the right, we need routing, because MLS 1 isn't aware of the networks connected to MLS 2. We will create simple static routes. I'll explain them here only briefly, but there will be a lesson later on both static and dynamic routing. Let's go through this first command. IP route is in the beginning of the command, that's clear. Then there's a network IP and a mask. That's the remote network that your router, or in this case MLS, will use this route for. And then there is the next hop IP address. In this case, that's 192.168.102. This IP address will be configured on MLS 2, so that's this link between MLS 1 and MLS 2, and we will set 192.168.100.1 on MLS 1 and 192.168.100.2 on MLS 2. So in this command, we're telling the router, if you get a packet whose destination IP belongs to this subnet, send it to 192.168.100.2, meaning send it that way. Okay, let's start the exercise and I'll explain this further in a simulation. The first thing we are required to do is configure host names and a banner with your name on MLS 1. Let's start with switch 1. Enable configured terminal hostname S1. MLS 1 enable configured terminal hostname MLS 1, and then banner, message of the day, cyber quins. Switch 2, same commands, enable configure terminal, hostname S2, enable configure terminal, hostname MLS2, switch 3, hostname S3, and then switch 4, enable configure terminal, hostname S4. Next, we are required to configure access interfaces. So on switch 1, that's going to be interface fast Ethernet 0/1, switch port mode access, switch port access VLAN 10, exit. On switch 2, interface F0/1 is switch port mode access, switch port access VLAN 10. And then fast Ethernet 0/2 is in VLAN 20. We won't be configuring any of the STP stuff in this exercise because we do not have any loops here. Let's move on to switch 3. So interface F0/1, switch port mode access, switch port access VLAN 30, and then F0/2 is in VLAN 40. On switch 4, we have interface fast Ethernet 0/1, switch port mode access, and that one belongs to VLAN 30. Next, we need to configure trunk interfaces, and those will be all of the interfaces between the switches, including MLSs, except between the two MLSs, because this link is going to be a layer 3 link, and layer 3 links are neither trunk nor access. So gigabit Ethernet 0/1, switch port mode trunk. And then on MLS1, 0/1, switch port mode. Oops. So on an MLS, we actually have to use the encapsulation command. I almost forgot about it. So trunk encapsulation.1q, and then switch port mode trunk, and then the same command on fast Ethernet 0/24, switch port trunk encapsulation.1q, switch port mode trunk. On MLS2, gigabit Ethernet 0/1, switch port trunk encapsulation.1q, switch port mode trunk. Interface fast Ethernet 0/24, switch port trunk encapsulation.1q, switch port mode trunk. On switch 3, we only have gigabit Ethernet 0/1. Let me check that. Yes, it's 0/1, switch port mode trunk. And then on switch 4, fast Ethernet 0/24, switch port mode trunk. Task number 4, manually create missing VLANs on switches in both networks. The reason why we will not use VTP in this case is because we have a limited number of switches, and we also have only 2 VLANs in each network. So we are missing VLAN 20 in switch 1. So I'm just going to say VLAN 20 and then exit. And on MLS 1, I will just create the 2 VLANs. So VLAN 10 and VLAN 20. And then on MLS2, I need VLAN 30 and VLAN 40. On switch 3, I have both VLANs, and on switch 4, I'm missing only VLAN 40. Next task, configure both MLSs as gateways for their own networks. So we need to do several things here. First thing is to enable IP routing so that we can use this MLS for IP routing or to add any kind of IP addresses. So I'm going to say IP routing first. And then let's create VLAN interfaces. So it's going to be interface VLAN 10. And define the IP address that's going to be the gateway IP for all of the computers in VLAN 10. That's 192.168.10.1 with a C-class mask. Next is interface VLAN 20, IP address 192.168.20.1, 255.255.255.0, and then exit. Let me do the same thing on MLS2 before I configure this layer 3 link. So on MLS2, I need first IP routing, and then interface VLAN 30, IP address 192.168.30.1, 255.255.255.0, and then interface VLAN 40, IP address 192.168.40.1, 255.255.255.0, exit. Now onto this layer 3 link. I'm going to go into MLS1, and this time we are actually going to open the physical interface, and that is Gigabit Ethernet 0/2. I'm going to say no switch ports, and then simply assign an IP address. That's going to be 192.168.100.1 with a /24 mask, so that's 255.255.255.0. And then on MLS2, interface Gigabit Ethernet 0/2, no switch ports, IP address 192.168.100.2 /24. Now I can even try to ping the neighboring IP address. So I'm going to say do ping 192.168.100.1. And we got 4 out of 5 successful pings. That's pretty good. And the only thing left to do now is to establish the communication between these two networks. First, I'm going to check if these computers can communicate in between each other and with their gateways, and then we will add those static routes. Okay, so PCA to PCB, that should work. And then PCA to PCC, that's working as well. And then PCA to its gateway, successful. PCC to its gateway, also successful. Let's check the other side. PCD to PCE, successful. PCE to gateway, also successful. On to static routes now. I'm going to look at the topology from here. Okay, so I need MLS1 to be able to reach these two VLANs over here, or these two subnets over here. MLS1 doesn't really care about the VLANs in this network, as that network is a remote network for MLS1. All I need on MLS1 is guidance on how to reach this network over here. So I need to tell MLS1, in order to reach these networks, send the packets destined for this network to your neighbor MLS2. So IP routes, and then type in the network you want to reach. So the first network I want to reach is 192.168.30.0, and then the mask for that network is ./24. And then the next hop for that network is MLS2, and MLS2's IP address is 192.168.100.2. In one of the following lessons, you will learn that you don't actually have to use the next hop address. You can also use the outgoing interface, so in this case gigabit Ethernet 0/2, but there are differences. I'll explain that later. For now, let's use the next hop IP address. Next routes, the only difference is actually the third octet in the destination network, so I'm just going to change it like this, and that's pretty much it. We can go on to MLS2 now. Here I need to explain to MLS2 how to reach these two networks on the left, so let's do that. IP route 192.168.10.0, 255.255.255.0, and then the next hop address. In this case, MLS2, when it wants to send packets to this subnet, it will send them to MLS1. And the IP address of MLS1 is 192.168.100.1. And then to add a route for network 20, I'm just going to do it like this, and that's it. Let's see if it works. PCA to PCD, successful. PCB to PCE, for example, successful. That's what we've wanted to see, so we can consider this exercise successful. See you in the next one.